Bismillahirrahmanirrahim. Assalamu alaikum, students. Today I'm starting a new course, namely first course physics. This is the title of my new course. First course in physics. This course is meant for a high school students, high school students. That is the students who are in 9th and 10th grade. This course is also meant for higher secondary students. Right? That is those students who are studying in 11th and 12th grade, right? This course would provide a first course in physics for those students who are pursuing foundation programs in physics at university or college level. And it is also useful for non-specialists, that is, those students who are doing degree courses in biological sciences, environmental sciences, environmental science, chemistry, and engineering, for whom physics is a subsidiary subject. This course is also suitable for training science teachers and medical students who need to develop a solid background in physics. And thing, most important thing about this course is that no previous, this is important, no previous experience of the subject which we are going to discuss, that is physics, is required. Because in this course, we start from scratch. This was about this course. So the title of this new course is First Course in Physics. This is meant for high school students, higher secondary students, non-specialists, those students who are pursuing degrees in biological sciences, environmental science, chemistry and engineering. And it is also suitable for trainee science teachers, those science teachers who are under training to teach science in schools. And the most important thing about this course is that no previous experience of the subject physics is required, because in this course we start from scratch. So I hope all listeners, all students going through this course will enjoy it. All teachers going through this course would enjoy it. There are many teachers, I have met many teachers at higher secondary level, at college level, who have other subjects like English literature, chemistry, physics, economics, or other subjects, non-physics subjects, but they are interested in subject of physics, so it will be useful for them as well. So let us start. So we'll start with the topic philosophy and practice in science. This is our first topic, philosophy and practice in science. You know, experiments play a vital part in the development of all branches of science. Over 500 years ago, there was a person called Nicholas Copernicus. Nicholas Copernicus gave a theory which is called heliocentric theory, which says that Earth and the planets orbit the Sun. Earth and the planets orbit the Sun. Imagine this idea over 500 years ago. At the time, there was rejection to this idea by the church. So church rejected this theory of Copernicus because it displaced the earth from the center of the universe. Church believed in geocentric theory. So this theory of Copernicus, heliocentric theory, was rejected by church because their belief was on geocentric theory, in which Earth was the center of the universe. Now, Copernicus had no experimental evidence to support his theory, right? So there was no reason to change the theory established in ancient Greece, that is geocentric theory, right? Then what happened many years after Copernicus? After Copernicus came the person called Galileo. Galileo is considered to be the father of the scientific age by many scientists, many scholars. He is considered to be the father of scientific age. Now, Galileo used the newly invented telescope. For what purpose? To observe the motion of the moons of Jupiter. Remember, Jupiter is one of the planets. You know it. It is the largest planet in the solar system. Now, Galileo used the telescope, which was newly invented, to observe the motion of the moons of Jupiter, and he realized that the planets orbit the Sun just like the moons of Jupiter orbit Jupiter. I repeat, he realized that the planets orbit the Sun just like the moons of Jupiter orbit Jupiter. So Galileo was arrested when he published his evidence for the Copernican view of the universe, but his evidence could not be denied as it was based on observations. So try to understand the point. Experiments play a vital part in the development of all branches of science, as the observations experiments made by Galileo established the Copernican view of the universe, right? Scientists now believe that universe originated in a massive explosion, referred to as Big Bang. The evidence is based on accurate and reliable measurements by astronomers. Now, in the mid 20th century, some astronomers theorized that the universe was in a steady state. Universe was in a steady state, that is the same now as it has always been. The steady state theory was rejected. Steady state theory was rejected. In favor of the Big Bang. Right? Big Bang theory. When astronomers discovered the presence of low intensity microwave radiation in all directions in space, radiation that originated in the Big Bang which is still traveling through space. The controversy was settled by experimental evidence which supports the Big Bang theory. Nevertheless, experimental evidence in support of a theory is not the same as proof, and just one experiment is all that is needed to disprove a theory. This is important. Just one experiment is all that is needed to disprove a theory, right? The more experimental tests that are found to support a theory, the stronger that theory becomes. This is the philosophy and practice in science. We make observations, we make experiments. If they support a theory, that theory is established. But if the experiments are against the theory is rejected. The theories give predictions. If those predictions are confirmed experimentally, theories establish it, and new theories come in their place. This is how science moves forward. And if we find a single experiment against an established theory, that theory is discarded, a new theory comes in which extends the earlier theory. This is an extension of the earlier theory, right? This is the philosophy and practice in science. Now let us move to next idea, the SI system of units. This is our next idea. Different units for the same quantity can be very misleading. For example, energy supplied by gas is measured in therms, right? Whereas energy supplied by electricity is in kilowatt hours. Now, if gas and electricity suppliers used the same unit, the consumer would be able to compare costs more effectively. Now, to remove this confusion, scientists have agreed on a single system of units to avoid unnecessary effort and time converting between different units of the same quantity. The system is called International System of Units or SI system. The system is based on a defined unit for each of the 7 physical quantities. These 7 physical quantities in SI system are called fundamental quantities with their corresponding units. They are called fundamental units. What are the quantities? So our SI system of units is like this. We have mass, we have length, we have time, we have electric current, we have temperature, we have amount of a substance, and luminous intensity. These are the 7 fundamental quantities in SI system, and their units, which are called fundamental units, are for mass we have kilogram, which we abbreviate as kg. For length we have meter, which we abbreviate as small m. For time we have second, which we abbreviate as little s. For electric current, the unit is ampere in our SI system, which we abbreviate as capital A. For temperature, the unit is Kelvin, which we abbreviate as K. For amount of a substance, it's mole, which we abbreviate as mol. For luminous intensity, it is candela, which we abbreviate as CD. So these 7 fundamental quantities, along with their units, these units make up the SI system of units, right? They are called fundamental quantities, and the units are fundamental units. The units of all other quantities are derived from the SI base units. For example, so let us talk about derived units. The unit of area, is the square meter. Abbreviate it as meter square because area is length times length. It becomes meter square. Unit of volume is the cubic meter. Abbreviated as m cube. Unit of speed is the meter per second. Meter per second. Remember, speed is distance over time. So unit of speed is meter per second, which is abbreviated as meter per second, or m s raised by -1, right? So this way we derive units for other quantities from the fundamental units. There's another idea called standard form. Or scientific notation. Idea is like this. If we have numerical values smaller than 0.001 and greater than 1000, what we do, we usually express them in standard form or scientific notation for convenience. Now, in this standard form, scientific notation, what we do, the numerical value, the numerical value is written as a number between 1 and 10 multiplied by an appropriate power of 10, corresponding to how many places the decimal point needs to be moved until the number is between 1 and 10. If the decimal point is moved to the right, the power of 10 will have a negative value, right? Let me give you some examples. First, the mean radius of the Earth is 636 0, 0, 0, 0 meter. 636, then 4 zeros meter. If we want to write this number, this radius, mean radius of Earth, in standard form of scientific notation, we need to move decimal point here in order to make this number between 1 and 10. So what we do in standard form or scientific notation, it is written as 6.36 into 10 raised to power 6 meters. You can see this number is between 1 and 10 to 6.36. Now what we have done, we have moved this decimal point from this point to this point. And in order to do that, when we move this decimal point in left direction, we have to see how many places we are moving it. 1, 2, 3, 4, 5, 6. That will be the power of 10 to be multiplied to 6.36. This is the scientific or standard form of this mean radius. Another example for this standard form or scientific notation. The wavelength of yellow light from a sodium lamp is 0.00000059 meter. Now, in scientific notation, standard form or scientific notation, we have to move this decimal point here to make this between 1 and 10. So it will become 5.9 into 10 raised to power minus 7 meter. See, we are here moving decimal point to the right. How many places? 1, 2, 3, 4, 5, 6, 7. So that is the power of 10, but it is negative because this number is less than 1. Overall, it's less than 1. So when written in scientific or standard notation or form, the power of 10 is negative, which I told you, if you move decimal point to the right, the power of 10 will be negative. This is how we express the numeric values smaller than this or greater than this, or any numeric value can be expressed in the standard form or scientific notation for convenience. Right? So this is all for today. Now I will give you homework. So the homework goes like this. Complete the following convergence. A will first 500 millimeter is equal to dash meter. Then second is 3.2 meter is equal to dash centimeter. Third is 9560 centimeter is equal to dash meter. Now part B. Part B, the first is 0.45 kg is equal to dash gram. And second is 1997 gram is equal to dash kilogram. Third one is 54,000 kilogram is equal to dash into 10 raised power dash gram. Let me check the question. Complete the following convergence. 500 millimeter is equal to dash meter. 3.2 meter is equal to dash centimeter. 9560 centimeter is equal to dash meter. Then I have 0.45 kilogram is equal to dash gram. 1997 gram is equal to dash kilogram. And 54,000 kg is equal to dash times 10 raised per dash gram. Remember, when we use certain prefixes, let me tell you about prefixes. The prefixes we use, they are numerical prefixes. Nano, if we use nano to certain quantity, certain unit, nano means 10 raised power minus 9. It is written as small n. Another prefix is micro, that is 10 raised power minus 6. It is written by mu. We use milli, that is 10 raised power minus 3, written as small m. We use kilo, that is 10 raised power plus 3, written as k. We use mega, 10 raised power 6, written as capital M. We use giga, which is 10 raised by 9, written as capital G. These prefixes are common prefixes. There are other also which we use in expressing units. So you can see first part you have to fill these blanks with the suitable numbers. This one is expressed in scientific notation. You have to fill dash here and what power of 10 we need to write. Now let me give you certain hint. Now 1 millimeter, mm means millimeter, means 10 raised to minus 3 meter, because milli means 10 raised to minus 3. So let me do this one for you. So it means 500 millimeter means 500, then milli means 10 raised to minus 3 meter. Now if I can write it 0.500 meter. Just multiplying by 10 raised to minus 3 means dividing by 1000. It is 0.500 meter. Or if I write it in scientific notation, then it will be 5 into 10 raised power minus 1 meter. Sorry, yeah, to make it 5, it is appropriate to write this way. 5.00 into 10 raised power minus what I did, 10 raised power minus 4 meter. Understand it? I am moving decimal to the right, so I have to multiply by 10 raised power minus 1. Then there is another 10 raised power minus 3, it becomes 10 raised power minus 4, right? Or I can say I am multiplying by 10, then I have to divide by 10. When I multiply by 10, in order to make it 5, right? I have to divide by 10. When I divide by 10, it was 10 raised to minus 4. 10 raised to minus 3 is already there, right? So the answer to this blank is 0.500, or in scientific notation, that is 5 into 10 raised to minus 4 meter, right? 5 into 10 raised power. Sorry, I have missed one thing. In 0.500, 10 raised power minus 3 is already done. It's 10 raised power minus 1. Sorry. Let me correct it. Is 10 raised power minus 1 here. I have used it 10 raised power minus 3 twice, calculated. Used it twice in the calculation. See, it is 0.500 meter. Now I multiply by 10, divide by 10. When I multiply by 10, it becomes 5.00. Then this divide by 10 comes up as 10 raised to minus 1. Right? So it's 5 in 0.00 into 10 raised to minus 1, not minus 4, because this 10 raised to minus 3 is already multiplied to this 500. So answer here is 0.500, or in scientific notation 5.00 into 10 raised to minus 1 meter, right? There's 500 millimeter, 510 raised to minus 3, because milli means 10 raised to minus 3. Then I multiply it by 10 raised to minus 3, means dividing by 1000, it becomes this. Then I write in scientific notation, I multiply by 10 in order to make it 5. I have to divide by 10 also. So it becomes this. Similarly, centi means 1 centimeter means 10 raised to minus 2 meter. Centi means 10 raised to minus 2, right? Kilo means 10 raised to 3. So 1 kilogram means 10 raised to 3 gram, right? So complete this. This is your homework. I have given you the details. So this is all for today. Don't forget to like, share, and subscribe my channel. Thank you. You can give comment in the comment box. Thank you. God bless you. Assalamu alaikum.